You send the binary sequence 10110110, but the receiver gets 10100110. Only one bit changed. Can a single incorrect bit really matter? For a text message, a photo, or even a banking transaction, the answer is absolutely yes. These mistakes are called channel errors, and every communication system must deal with them. In the previous lesson, we learned that communication systems encode information to improve reliability before transmission. However, even the best encoding techniques cannot prevent every problem. Once a signal enters the communication channel, it is exposed to noise, interference, attenuation, fading, and many other impairments. As a result, the receiver may not always recover every transmitted bit correctly. Some bits may change from 0 to 1, while others may change from 1 to 0. Even a few incorrect bits can significantly affect the quality of the received information. This raises an important engineering question. Why do these errors occur, and how do engineers design communication systems that continue working reliably despite them? A channel error occurs when one or more transmitted bits are received incorrectly after passing through a communication channel. The transmitter sends the correct bit sequence, but imperfections in the communication channel modify the received signal. When the receiver decides whether each received symbol represents a 0 or a 1, noise and distortion may cause an incorrect decision. Channel errors may occur individually as random errors, or several consecutive bits may be affected together, creating burst errors. Modern communication systems are designed to detect, minimize, and often correct these errors automatically. Intuitively, imagine copying a phone number while someone is speaking in a noisy room. Most digits are heard correctly, but one digit is misunderstood. Although only one number changes, the entire phone number may become unusable. Digital communication behaves in much the same way. Physically, consider a smartphone downloading a file over Wi-Fi. The transmitter sends millions of bits every second. As the RF signal travels through walls and reflections, thermal noise and interference may corrupt some transmitted symbols. The receiver converts the received waveform back into bits, but occasionally a symbol is interpreted incorrectly, producing one or more bit errors. Mathematically, engineers evaluate communication reliability using the bit error rate, BER, which measures the probability that a transmitted bit is received incorrectly. Lower BER values indicate more reliable communication, while higher BER values suggest poorer channel conditions. Channel errors are one of the primary design challenges in RF engineering. Cellular networks, satellite systems, Wi-Fi, Bluetooth, fiber optic communication, and deep space missions all experience transmission errors due to imperfect communication channels. Engineers reduce channel errors using multiple techniques. They improve receiver sensitivity with low-noise amplifiers, apply forward error correction coding, choose robust modulation schemes, increase antenna gain, implement retransmission protocols, and continuously adapt transmission parameters according to channel quality. At the system level, communication performance is often evaluated by measuring BER under different signal-to-noise ratios, transmission powers, and propagation environments. Channel errors demonstrate an important reality of communication engineering. Perfect transmission is rarely possible. Instead of trying to eliminate every error completely, engineers design systems that can tolerate, detect, and correct errors while maintaining reliable communication. A common misconception is that communication either works perfectly or completely fails. In reality, communication quality exists on a spectrum. As channel conditions become worse, the bit error rate gradually increases until reliable communication is no longer possible. This naturally leads to another important question. How much information can a communication channel reliably carry before errors become unavoidable? In the next lesson, we will explore the channel capacity idea and discover the theoretical limits of communication systems. In this lesson, we learn that channel errors occur when transmitted bits are received incorrectly because of noise, interference, fading, and other channel impairments. We also introduced the concept of bit error rate and saw why minimizing transmission errors is one of the primary goals of modern communication systems. In the next lesson, we will explore the channel capacity idea and discover the maximum amount of information a communication channel can reliably transmit. If you found this useful, like the video, subscribe, and follow for the next lesson.